Okay, now actually it says these are integrals that lead to inverse hyperbolic functions, but I just want you to understand you're not actually going to see it say inverse hyperbolic sine or inverse hyperbolic cosine in here. But remember that the inverse hyperbolic functions actually involve natural logs, because if you think about it, the inverse hyperbolic functions are actually based on the function e to the x. And if you think, what is the inverse of e to the x? It's natural log of x. So if the hyperbolic functions are functions involving e to the x, then it would make sense that the inverse hyperbolic functions would involve natural logs. So you'll see that these formulas here, like the first formula here says if you integrate du over the square root of u squared plus or minus a squared, then that would equal natural log of u plus the square root of u squared plus or minus a squared. So if this formula had the plus in it, then the result would have the plus in it. If this formula had the minus in it, then the result would have the minus in it. Okay? And then here's a formula for if you integrate du over the square root of a squared minus u squared, then you get 1 over 2a times the natural log of the absolute value of a plus u over a minus u plus a constant. And then here's another one with the plus or minus in it. If you integrate du over u times the square root of a squared plus or minus u squared, that's actually minus 1 over a times the natural log of a plus the square root of a squared plus or minus u squared all over the absolute value of u plus a constant. So these are fairly obscure formulas that you probably wouldn't be required to remember, but you could certainly might have to apply them in a calculus class. So let me go ahead and start with this first example here. So in this example, I have dx over the square root of 4 minus 9x squared. Okay, now this one, actually, since I have a constant squared minus a function squared here, I'm going to think of it, I'm going to see if it might work for this one where I have a squared minus u squared in the square root. So if I'm trying to get it to work for this middle formula, then I would have to say, okay, what do I square to get 4? Well, that would be 2. And then what would I square to get 9x squared? Well, that would be 3x, so u would be 3x. And then if u is 3x, du would be 3dx. Now, since I only have dx up here, let me go ahead and multiply the numerator by 3 so that I actually have du in the numerator. So if I multiply dx by 3, that gives me 3dx, so that's actually going to be this du right here. Now, if I multiply that by 3, I have to multiply 1/3 on the outside. It looks like I lost the 1/3 here, so I'm going to correct this as we go. So the 1/3 has to carry there. Okay, now let's just talk about this integral now. Now this integral is 3dx, which is du, over the square root of 2 squared minus u squared. Okay, so let's think about what that comes up. I'll multiply the 1/3 when I'm done. So let's just forget about the 1/3 for a minute, and let's just focus on this integral. Okay, so this integral would be 1 over 2a, so that would be 1 over 2 times 2, because a is 2, so that would be 4, times the natural log of a plus u. Well, since a is 2 and u is 3x, we would have 2 plus 3x here, and then over a minus u, so that would be 2 minus 3x there. Now if I bring the 1/3 in, I've got to actually multiply all this by 1/3. So multiply that by 1/3. And so all you have to do there is just change this 1/4 to 1/12 to correct my little error there. So we'll just change this to 1/12. and that'll be correct. So you have 1/12 times the natural log of the absolute value of 2 plus 3x over 2 minus 3x plus a constant. Okay, now on this next one, I've got e to the x dx over 1 square root of 1 plus e to the 2x dx. So now, since this is a plus, I'm going to have to use either the first one or the third formula, but look, I don't have any function outside of the square root, so that leads me to this first one. So think of this as, think of this formula here as we try to solve this. So now I'm going to write this as a would be 1, because you just have to say what would I square to get 1, and then u would have to be e to the x, because e to the x would be what I would square to get e to the 2x, right? Okay, so if u is e to the x, then du would be e to the x dx. So now let's look at this. I have e to the x dx over the square root of 1 squared plus e to the x quantity squared. And so that would simply be, if I do a little bit of substituting, this is du, so I have du, and then over the square root of 1 squared plus u squared. Okay, now that's this formula, because if I have u squared plus a squared, that's the same as a squared plus u squared. So so it's this formula with the plus case. That's what we've got. Okay, so it says that this formula will result in this formula. The result of this formula is going to be the natural log of u. So I put the natural log of e to the x, that's my u, then plus a square root. So plus a square root of u squared, and u squared is e to the 2x, plus a squared, and a squared is 1. And so that's it. Then just put your plus c. So that's the natural log of e to the x plus the square root of e to the 2x plus 1 is what that integrates to. Okay, let's take a look at this next one here. So on this one, I have dx over x times the square root of 4 minus 9x squared. Now on this one, I do have a function that resides outside of the radical. So I'm probably going to be dealing with this one. So on this one, let's see what I can do. First of all, the square root of 4 is 2, so a would have to be 2. And the square root of 9x squared would be 3x, so the u would have to be 3x. Okay, now du would be 3dx. Okay, so, alright, so I can fix this pretty easy. If I multiply the top and bottom by 3, I'm going to do this a little different this time. I'm just going to multiply the top and bottom by 3. Now that'll do two things for me. That'll make the 3dx on top be my du. And that'll also mean that with the x, since I have a 3 now with the x, the 3x is actually serves as the u. So therefore I have du over u, right, times the square root of 2 squared minus u squared. So now that fits this formula up here. And so if I apply that formula, let me minimize this a little bit so we can see the formulas. Okay, so I'm going to have minus, so I have minus 1 over a, and a was 2, so I have minus a half, times the natural log of a, which is 2, plus the square root of a squared. And let's see, what did I have here? I may have this, it's minus here, so it would be 2 plus the square root of 2 squared minus u squared, and then all over the absolute value of u. And then the last step, just replace u with 3x. So I end up with minus 1/2 times the natural log of 2 plus the square root of 4 minus 9x squared over the absolute value of u, which is just the absolute value of 3x. And then, of course, plus your constant. So, and now I want to finish this with some other intervals and tricks. Take a look at this one. Right here I have 1 over x minus 1 times this square root. And so what I'm going to do is I'm going to try to get a perfect square in here. So I can actually factor a 4 out of this, and if I factor a 4 out of this, that'll give me 4 times x squared minus 2x plus 3/4. And then I'm going to complete the square in here. So to complete the square in here, oh wait, before I complete the square, I'm going to go ahead and take this factor out. Since the square root of 4 is 2, I'll pull that out here and have 2 times the quantity x minus 1. Okay, then inside this, I'm going to complete the square. So to complete the square, half of negative 2 is negative 1, then square it, you get 1. So I'm going to add 1 and then take away 1. And when I add 1, that makes this be a perfect square trinomial. So I can write that as x minus 1 quantity squared. And then 3/4 minus 1 is minus 1/4. Okay, so now I can say that u is x minus 1. And du would just be dx. And also, let me just go ahead and tell you that a would actually be 1/2, because just if you square a, you get 1/4, which is what I have here is 1/4. Okay, so now I factored the 1/2 out here, so I got the 2 out of the denominator and put it out here just to make it easier to see. So now I have du over u times the square root of u squared minus a squared. Okay? Now since this is u squared minus a squared, not a squared minus u squared, I actually can't use this formula up here. But there is another formula, and if you go look it up, you can see that when you have du over u times the square root of u squared minus a squared, it's actually going to equal 1 over a times the arc secant of the absolute value of u all over a plus a constant. So 1 over 1/2 times 1/2 is just 1. So those fractions cancel each other out. And then I have arc secant, absolute value of u. Well, u is actually what? X minus 1. So I have absolute value of x minus 1 all over 1/2, and then when you flip the half over and multiply, you get 2 times the absolute value of x minus 1. So that's just arc secant of the absolute value of x minus 1. Now there's some other tricks you can do here when integrating, and if you hadn't figured out, I've kind of deviated away from the inverse hyperbolic formulas. So on this one, I'm just going to tell you this real quick. On this one, you can actually square this binomial, and then you can integrate these terms separately. And what you can do is you can actually replace the tangent squared with the identity secant squared minus 1. And then you'll get 2 secant squared and then 2 secant tangent x minus 1. And each of these, you have a formula you can use to integrate these. The secant squared becomes tangent, and the secant x tangent x integrates to secant, and then the minus 1 becomes x. Okay, one last one here, and I'm going to cover this kind of quickly here, but 1 plus cosine of 4x can be written as a cosine squared function, and then since that can be written as cosine squared of 2x, 1 plus cosine 4x over 2 is cosine squared of 2x, and then if you multiply both sides by 2, you'll get a value that represents 1 plus cosine 4x. So we can actually plug this back into the square root, and then when you take the square root of cosine squared, you just get cosine, so we get cosine of 2x. The 2 has to stay in the radical, so we get square root of 2 times cosine 2x. And you shouldn't really have much problem integrating cosine 2x. You'll find that it's just going to be sine 2x over 2. And so when you integrate that, you get sine 2x over 2 times square root of 2. And so you're just going to get square root of 2 over 2 times sine of 2x plus c. So these last three I just kind of threw in there to wrap up and show you some tricks, some other tricks that you can use on integrating. This pretty much completes all of the integrals that one would see in, say, a typical Calculus 1 course. And now on the next series of videos, I'm going to go into some Calculus 2 topics that shows you all of the ways that you can evaluate integrals in Calculus 2.